So let's now look at questions number 17 through 20. And you'll see I've done some work already on the graph here. What I've done is I've labeled some of the points with their x and y coordinates, and that's going to help us answer the first couple of questions. So question number 17 is to find AB, and they're both on the same horizontal lines. I could simply count across that horizontal line 1, 2, 3, 4, 5. So AB is equal to 5. That is the answer for number 17. And if for some reason it wasn't entirely obvious that they were on the same horizontal line, you could find that out by looking at the fact that they both have the same y-coordinate. They both have the same y-coordinate of 2, which means that they're on the same horizontal line. Question number 18 is to find the distance between B and F. These 2 points are on the same vertical line. So you can simply count down and count the number of boxes. You don't have to use any other method. So we've got 1, 2, 3, 4. So BF is equal to 4. Another way to notice that they're both on the same vertical line is to notice that they both have the same x coordinate. Both B and F have an x coordinate of 2. So therefore, that's another way of seeing they're on the same vertical line. Number 19 asks us to find AE using the distance formula. Let's go back to our graph over here. I've already drawn in line AE, and you can see I've also already labeled x1, y1, as well as x2, y2. So we've done some of the preliminary work already here, and you can see the coordinates of A are -3, 2. I'm calling that point 2, so x2 equals x2, y2. And E, which I'm calling point 1, has coordinates -2 and 0. I'm calling those x1 and y1. So I've made a little chart down here of all of the x1s and y1s and x2s and y2s, and you can check to make sure that it is correct. Now I'm going to go ahead and remember my distance formula and plug these numbers in. So my distance formula is that D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's it. That's the entire formula. So knowing my x1, y1, x2, y2, I can plug numbers in and solve. x2 is -3 minus x1 is -2 squared plus y2, which is 2, minus y1, which is 0 squared. Now let me simplify a little bit here. We've got -3 minus a -2. The 2 minus signs become positive. As you know, subtracting a negative is the same as adding a positive. So that gives us -3 plus 2 squared plus 2 minus 0 squared. So now let's continue to simplify. What is -3 plus 2? It's -1. -1 squared. And what's 2 minus 0 is 2 squared. This further simplified is equal to -1 squared is 1. 2 squared is 4. D is equal to the square root of 5. Okay, so the answer is the square root of 5. So the answer to number 19 is the square root of 5 equals AE. That is the distance of AE. And now let's go on to number 20. Question number 20 asks us to find AD using the Pythagorean theorem and to show our work. Well, let's go back to this graph and let's draw the line segment AD. Okay, let's draw a line segment AD. Draw it in pencil, so it'll look different from the other lines. And I've got the line AD, and now what I've got to figure out is what is the third point of that right triangle. Remember, when you're using the Pythagorean theorem, you're always finding the distance of a hypotenuse. So if you'll recall, either you could see that this is the point by just seeing that this line is horizontal, and then this line would become vertical, or if you don't see that, you could always take the x-coordinate of the higher point, the point that's higher on the y-axis, and then the y-coordinate of the point that's lower. That would give you the point -3, comma, -2. And you could plot that point, and that point is going to be the third point of the right triangle. So let's go ahead and plot -3, -2. It would be -3 on the x and -2 on the y. That would be right over there. So this would be our point. That would be the third point of the right triangle. Let's complete it. Let's call this point, well, this is A, this is D. Let's call this point H. Okay, so it's a brand new point we just created. Let's go ahead and draw the line segment AH. Okay, and let's draw the line segment HD. Okay, and this is where our right angle is. And we've got our right triangle now. So let's go ahead and let's count the lengths of the two sides so we can calculate the hypotenuse. So let's call, well, we're going to just call this by the name of its measure. So let me zoom out a bit, and let's write our formula here. We know that we've got AH squared, which is the length of this side, plus HD squared has got to equal to AD squared, which is the hypotenuse of the right triangle. So let's plug the values in. How long is AH? We can simply count down the number of squares. 1, 2, 3, 4. This is 4 squared. And how about HD? We can simply count across. 1, 2, 3, 4, 5, 6, 7, 8. Let me count that one more time, make sure I'm right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. HD is 8. This is 8 squared equals AD squared. So let's solve. 4 squared is 16. 8 squared is 64. So 16 plus 64 is AD squared. And 16 plus 64 is equal to 80. So 80 is equal to AD squared. And finally, AD is going to be equal to the square root of 80, because we could simply take the square root of both sides here, and the square root cancel out. Okay, so the answer to number 20 is that AD is equal to the square root of 80.